This is abusing software-defined networks. The obligatory, who I am page. Okay. Gregory Pickett, Hellfire Security. I think a lot of people have been talking about what they do. I've shifted back and forth between red team, blue team. Actually started out blue team, did some red team, going back and doing blue team again, a lot of intrusion analysis. So we do both pen test assessments, a lot of people do, of course, and then managed security services. So that's what I'm doing now there, going back to blue team, doing managed security services. So my contact information, should you wish to speak to me later about this. Okay. An overview of today's talk. What is it? What is software-defined networking? It's new for some, not for others. We'll explore a little bit about that. Tell you, what is software-defined networking, and then of course exploiting it, because we all like to break things. So we'll be breaking a lot of things today. And no matter how much fun it is to break things, we are also here to help. Right? We're breaking things so that they can be fixed. So we're going to talk about some solutions, immediate solutions, as well as long-term how to handle software-defined networking. And then moving forward, okay, because we want to talk about this as a bigger picture, not just the immediate controllers we're seeing today and the protocols they use, but the bigger picture of SDN and how we move forward with that. And then finally, wrapping up, because I will be introducing a toolkit today. Right? I believe there's a DVD. There's obviously a version there. There'll be updates, that sort of thing, where you can get the toolkit, updates to it, as well as some links for more information about SDN. Okay, so let's start with modern day networks. If we have some people here, we probably have a number of people here involved in networks. Very interesting animals. They're first off very vendor dependent. You buy the equipment. Very unique way of implementing standard features. Then you have unique features. Then you have the command lines you have to learn just for that piece of equipment. Right? You start adding these things out one after the other and become difficult to scale. All these different moving parts, complex, prone to break. Right? You have a very distributed configuration. Each device has its own unique configuration and its own view of that network. And there's a consistency that creeps in because we make errors, we make mistakes. Okay? And these boxes, they use inflexible protocols. We are using what is given to us, and they're difficult to innovate that because they're shared, and we can't just make changes to these things. We don't develop them, we don't produce them. We can't just make changes that we might need in the protocols. And the protocols are unable to consider other factors besides just the network itself. We talk about bigger things now. We talk about application needs. Application space is very important now. We talk about business needs that these sorts of protocols can't adapt to. Right? So we have this very large, very fragile network, and we find that it's then very difficult to change. You make it one change, can be a bit fragile, and everything breaks. Okay, so we're very careful. We're very guarded about our network because of these issues. They work well, but they take some care and some feeding, as it were. Okay. So enter software-defined network. The idea is to separate the control and data plane, where the forwarding decisions are made by the controller, and the switches and routers just forward packets. Right? So with the controllers, they are programmed with all the intelligence, have the full visibility of that network, and can consider the totality of the network before making any decisions. And the nice thing is everything's centralized. It can be very consistent and can enforce a granular policy across the network, right? Kind of the holy grail of the network, from a central location. Okay? This leaves the switches as bare metal only, and which that means at that point then it can be any vendor, hardware or software. It really doesn't matter. They become more of a commodity. Okay? Now, the reason why we went this direction is because, or we're choosing to go this direction, is because it solves a lot of problems in the network space. First off, costs. Right? With software-defined networking, it's very inexpensive. Right? With commodity switches, the hardware is much less expensive. So we like that, of course, on the business side. And then on routing, BGP. Lots of things that we would like to do or have problems doing currently with routing using BGP. There are lots of different problems that you can solve there with this. Right? Maintenance dryouts. You can go ahead and actually route traffic around a device before you take it out of service to do updates or do repairs on it. You can give the customer a chance to choose the point of egress. You can add additional factors to BGP security, maybe reputation, before it chooses the next hop. Also faster convergence. granular peering at the internet exchange points. It's no longer a situation of all or nothing. And so a lot of problems are solved with software-defined networking. It also expands a capability, right? It allows you to do real-world slicing of the flow space, right? Move beyond that cloud, start slicing up the network as you choose, as you wish to, for the best use of the enterprise. It also allows you to go from server load balancing to actual network load balancing, gaining efficiencies that we have not seen so far. Okay? And of course, for security, this is where people have really been having a good discussion about what can SDN do for security. It allows you to add layers to that access control. You get to consider other factors such as maybe time of day, right? Maybe just dates and weekends versus weekdays. All sorts of things to the access control. You can add additional layers. And then, of course, adaptive traffic monitoring. Monitoring does no longer has to be from a fixed point. You can actually move your monitoring along with the traffic to better keep track of your network. And then, of course, when you have the central location where you're able to see the network and then programmably change it, you can then work toward attack detection and mitigation, make the actual network defend itself. Do lots of responses that really add a lot of capabilities on the security side to add more dimension to what you can do on the network and to protecting the network. Okay? So we see lots of great capabilities open up, not just new operations or different operations that we can do with what we're currently carrying out in our network, but also what we can do additionally with software-defined networking. Okay? So software-defined networking is actually not a new thing. It's something that they've been working toward for a while. It started off with some other protocols that they were adapting to kind of get the same kind of centralization, the kind of control and consistency that software-defined networking, what they're hoping to get with software-defined networking. SNMP, extensions on BGP, NetConf, Lisp, PSEP. But there was always something missing because its primary purpose, or the primary purpose of these protocols was not software-defined network, not that functionality. All right, so they went ahead and they started from the ground up and designed protocols specifically to implement this paradigm. Okay? OVSDB for the virtual space and network-wide, bridging both virtual and physical, OpenFlow. Okay? So we were talking about OpenFlow today here. It is something that is expanding, seems to me has the most support, and is what is being used by most of the controllers rolling out now with OpenFlow. Establishes elements of that paradigm, the controller, a secure channel for the controller to communicate over with the forwarding elements. Right? So we have the switches and routers being established there, their roles. It defines at those forwarding elements a forwarding process, and then a messaging format so that those forwarding elements can communicate back with the controller and kind of get updates to what they're supposed to be doing with packets when they encounter them. Okay? Now the forwarding process, this should look very much like a firewall. Right? A forwarding element will receive a packet. It will check the flow table. If a match is found, it will execute that action. If no match is found, then it goes ahead and sends that packet to the controller. Controller has its policy, right? Makes a decision, passes that decision on to the forwarding element. Forwarding element will update its flow table, execute that action, and then any time it encounters that same type of packet, the match has the same match, it will carry out that action. So it gets updated, does not have to keep going back and forth. Okay? Now these flow tables, they are very much, as I said, like firewall rules. Match action entries, 12 fields available for matching, and their wildcard matching available. So you can instantiate rules for groups of packets, not just individual packets. Okay. Brief kind of a graphical representation of that relationship. In this case, we have an OpenFlow switch, flow table, that secure channel that communicates with the controller over using the OpenFlow protocol. Okay. We all like pictures, don't we? So there's one. I don't have a lot. Some people have a lot. I don't have a lot of pictures. Okay. Some leading platforms. There's a lot coming out right now, but these are some of the more prevalent ones. With Cisco, of course. Cisco has their own proprietary platforms coming out. HP has them, IBM, and then there are some open source ones. All right, the ones we get to get our hands on right away without spending the big bucks. We have Knox, Pox, Ryu, and Floodlight and Open Daylight. Specifically looking at those today, because they are promoted as production ready. So I wanted to look at these and to see what we would get if we went ahead and put those into production. Okay. So first off, Floodlight. It is an open source Java controller, primarily an OpenFlow based controller. supporting OpenFlow version 1.0. It is a fork from the Beacon Java OpenFlow controller maintained by a single outfit, Big Switch Networks. Okay. In fact, it is the basis for their commercial product, Big Switch Fabric, which is getting a lot of press right now. Then we have OpenDaylight, an open source Java controller. Many southbound options, including OpenFlow. It supports 1.0 and 1.3. It too is a fork from the Beacon Java OpenFlow controller. And instead of being maintained by a single outfit, it is a collaborative effort under our, a very popular group, of course, we have a lot of support for, the Linux Foundation, being worked on by a number of people under that effort: Citrix, Red Hat, Ericsson, Hewlett Packard, Brocade, Cisco, a lot of big names. Okay. All right, so I said I don't have a lot of pictures, but I have some. All right, so we have networks. They work well, but they take a lot of care. And so we look to improve them. We look to solve some of our problems. We have a lot of great problems to be solved, as well as capabilities we can expand on. So according to the industry, according, of course, to the material that you get if you read about these, everything is going to be puppies and rainbows, right? But of course not. I wouldn't be here if everything was going to be that wonderful. Okay? So not exactly. All right, there are a number of weaknesses in the protocol itself. Encryption and authentication are defined within the standard via TLS, but it's more of a suggestion than a requirement. It started out very good. It said TLS, you must have TLS for that secure channel. But then it started heading backwards. Right? 1.0 said TLS, 1.4 said, if you want to use TCP, it's okay. Now what we find is if you give people the opportunity to be less secure, what do? All right, maybe they choose to be less secure. So we see lots of problems here. All right, controllers. First off, Floodlight has no support for TLS. In fact, I don't believe they even have plans for it. Okay. OpenDaylight, it's supported but not required. Okay. This looks bad, but it gets worse. If you look at the switches, all right, Arista no, Dell no, HP no. Some yeses, Brocade, Cisco, Extreme. What we find is there are more no's than yeses. And what we're finding out here is that even if you want TLS, you might have a hard time. You probably have a hard time getting that nice match between a controller that supports TLS and an endpoint that supports TLS. Okay? It's actually worse than that. What you find in the configuration settings for all these, there doesn't seem to be an option for certificates. No certificates, no authentication, which pretty much means anyone that can reach it can be an endpoint or can just choose to attack it, which of course that's what we like to try to do, right? So what we find out here then is that the way they're currently implementing a standard, or not as it seems to be, we don't see a complete implementation of that standard. We're going to have a lot of issues here with our environment because we're going to, first off, if you're lucky, you may get that matching set of controllers and switches that support TLS, but for the most part, a lot of people won't. So a large number, most people will have problems with information disclosure and modification if you're a man in the middle, because you won't have that right matchup. And then because we don't see authentication support across the board, there's one vendor for TLS, everyone is then going to have a problem with denial of service issues. Okay. So speaking of denial of service issues, OpenFlow, as we can already run this through our mind, right? Centralization, it entails dependency. Dependency can be exploited. So if we know that we're all going to have a problem with this, we're going to have to address this, it's important to look at how our vendor's handling it. Right? So Floodlight, that was explored by Solomon, Francis, and Etan. They did a study. Their results, what they did, and the results are on SlideShare. I recommend looking that up, seeing what the results were. I'll give a brief summary here, of course. Their results, well, that Floodlight handles it poorly. It was just a couple instances of cbench. I don't know if you're familiar with cbench. Okay. Kind of allows you to, it's like a little bit like a packet crafter. Allows you to throw up some traffic and generate traffic and then stream it for testing, stress testing as well. And they used it here for that. All right. So they set up a few instances of cbench, and they threw packets at the Floodlight controller, and down it went. Okay. Well, it's a little ironic because there's an option within Floodlight, rate limiting. You can turn on, you can recompile it, turn on rate limiting. They found that when you flip that switch, when you enabled it, recompiled it, it actually went down faster. So yeah, you turn on the rate limiting and it actually kills it. So not so good. So it's handling and porting. Now Open Daylight, it is unknown, but worth investigating because it is Java, right? For God's sake. So now to experiment, you either read, do the work of Solomon, Francis, and Etan, or to play with Open Daylight. I recommend if you have a controller already there or planning to. In fact, I'll show you how a lot of us will be doing this very soon. To play with these controllers or your own, we have some tools here. These tools, I started developing them to learn more about OpenFlow and the controllers. And so I started building these tools, and they kind of start like a seed, and I started building out on each tool, adding more capability, shifting the focus a bit. So what I started with, this is the first tool to the toolkit, switch. Just impersonates, and what better way to learn the protocol than to create or simulate that kind of endpoint. Learn the messages that have to be exchanged. So switch actually impersonates OpenFlow switch. It exchanges the hellos with the controller. It receives and responds to a feature request. It receives and responds to a configuration set, a configuration get. It does all of the echo, receives the echo request, returns the echo reply. It establishes that relationship, maintains that relationship. And you can run this yourself and just see how the relationship proceeds with the controllers and what kind of information is passed back and forth. Now, of course, I had an ulterior motive in mind for doing this. I wanted to see, what we could turn this into. All right, so I then took and built on that and did OFlood. Right, so it's very friendly. It establishes that initial relationship, pretends to be just your neighborhood-friendly endpoint. Right? Then it goes ahead and just unloads on the controller. Right? So if you look at the previous slide, there's 12 matching fields. All different combinations. Do the math. You get millions and millions and millions of packets. It's Python. You compile it. You're a little bit faster, right? Throw up a couple instances yourself and see how your controller responds. Right? Have a little fun. Right? So I'd highly recommend that. Highly recommend that. Okay. Now, before I move on to the controllers where the fun really starts, I want to mention the debug port. All right, there's no encryption. This is for OpenFlow. No encryption, no authentication. These are the kind of things that we love, of course, right? You just get full control of the switch, right? All via the dpctl command line tool. Right? And as I said, they're not really fully implementing a standard. They're kind of moving along. TLS is there in some instances, but not completely implemented. Right? As they move along, get toward the rest of the standard, they're going to start pushing out the debug port. All right? Debug port's not really there yet. So it's not a problem now, but as they start implementing the standard fully, it's going to start showing up. So keep your eyes open because this is just an open door. All right? So keep an eye out there for this. Not a problem now, but soon will be. Okay. All right, so protocols, of course, are fun. I find them fun. Right? Some people it's more of a Chinese water torture, but I like protocols. It's worse with the controllers. Right? Floodlight. There's no encryption for the northbound HTTP API and no authentication for the HTTP API. Open Daylight seems to be better. Not really. There's encryption on that northbound HTTP API, but it's turned off by default. Authentication on the northbound, but it's HTTP basic authentication. Default password is weak, and strong passwords are turned off by default. Right? Yeah, wonderful. It seems like it's great. Well, it seems a little better than Floodlight. Not really. Because I'm going to show you an exploit. Now, there's actually a lot of stuff packed into Open Daylight. I'll show you an exploit that's going to allow you to kind of step around that. All right, so while Floodlight, you actually have direct access to it, gain control of the network it supports. Open Daylight, it's more indirect. You're going to take a kind of a detour. So we're still going to end up in the same place. All right. Information disclosure through interception for both networks, supported by these controllers, topology, credentials on the Open Daylight side, information disclosure for both, topology, targets, lots of juicy stuff. All right. Both of those also topology, flow, and message modification through unauthorized access. Add access, remove access, all the fun stuff. Hide traffic, my personal favorite. And then changing traffic. Right? Flow rules allow you to actually modify traffic, allows you to just change any aspect of the header, not every, but most aspect of the header, VLANs, we like that. Okay. Now, before you dig into that network, before you gain control of that network, either directly on a Floodlight-based network or indirectly on an Open Daylight network, you have to find them. Right? So OpenFlow, the OpenFlow-based services are currently listening on TCP port 6633. There's a new port defined though, it's official now. You can find it on IANA site. It's 6653. The tools, all the tools, they default to 6633, but they accept an alternate port. So if you have a controller that's on the new port or they start moving it over with updates, you can point it toward the different port. Yeah. Now, in order to identify one of these OpenFlow-based services, you look for that hello. You exchange that hello. If you get a feature request, then you know that you're dealing with a controller. If you don't, then it's a switch. Okay. So the next tools in the toolkit, OFCheck, identifies OpenFlow-based services and reports on their versions, compatible with any version of OpenFlow. These tools were designed for discovery. So what you're going to go ahead and do is give a list of hosts that potentially have an OpenFlow-based service on them. Then you're going to take that, let's say like 100, maybe 255. You got a full subnet that you're going to look at, or old school subnet. So you go and give that to OFCheck. You'll get a smaller list, 6, 5, 4. Who knows what you've got exposed there. Then you'll give that smaller list to OFENUM. OFENUM will then enumerate the endpoints, report on the type, will tell you whether it's a controller or a endpoint, right? Switch or a router. It's compatible with any version of OpenFlow. And just to throw that in there, there's also an Nmap script as well. Throw that in there. You can use that with the tools you already have. Okay. So let's go ahead and see how easy that is. Got that set up, so we have OFCheck. List of potential targets here. There we go. This network's much faster than the hotel. All right, so OpenFlow service version 1 found at 192.168.267. Easy, I kind of knew that already, but it still looks good. So now we're going to go ahead and say we had that smaller list. And it tells us that it's a controller. So it got that feature request back. And so very quick, very easy. But I actually use this, I poked around the internet a little bit. If anyone is interested, yes, there are controllers out there already. All right. So it's a very quick, very easy Python. Take a look yourself, how that runs. Okay. Now, of course, what's next, right? All right, so once we found this controller, this right behind this controller is a small little network. One admin host, 2 user hosts, 1 server, and 1 IDS, which I will henceforth call the sensor. It can be anything, but it's going to be something like an IDS. An attacker, me, I'm going to save the fun stuff for myself. I'm going to identify targets. I'm going to enumerate ACLs. I want to know what they're protecting, of course. And then I'm going to find sensors to see if anyone is listening. Our tool to do that today is OFMap. It downloads flows from an OpenFlow controller, and it uses those flows to identify targets and target services, to build ACLs, to identify sensors. It works with Floodlight and Open Daylight via JSON. It will actually auto-detect for you, and will use the correct syntax. Not only will this take an alternate port, but if you have to end up using the exploit, because the exploit, it kind of gives you everything on the Open Daylight. I'll just say that. It gives you everything on the Open Daylight box. Everything includes the credentials for the northbound HTTP API. If you have to go that route, you can get the credentials there. This takes alternate credentials. It will try the default first. Okay. But if you have to put them in there, you can. All right, so demonstration. All right, so very simple. This is probably my most user-friendly tool ever. Nice little menus. All right, so actually I got the wrong one. I'll exit, number 6. I guess you know what the next tool is called. All right, so the first thing we're going to go ahead and do is map the network, which is basically a request to the controller, give me all of your flows. Nice little feature here. It tells you what switch you're connected into, which I'll need in just a few minutes. So let me grab that. See, nice little messages and everything. All right, so you can list the flows. You could do it here. I don't recommend doing that on a production network. It will be massive. It will be all the flows for every switch, every forwarding element on the network. So don't list them, but you can go ahead and dump them on number 7. It dumps it to a file for editing, grepping, whatever you need to do on it. All right, so the first thing I'm going to go ahead and do is look at the targets. There are targets. 215 happens to be me, and there's 225, 227, etc., etc. Then I want to, of course, as someone who has a high degree of interest in the network, not necessarily good interest, but that remains to be seen. But I'm going to go ahead and see what is currently being blocked, or what I'm not allowed to currently get into, because of course that is what interests me the most. So number 5 is the ACLs. Okay. So 225. Anything that comes from me to 225 is going to be dropped. Now, I happen to know that 225 is the server, so that's great. That's actually the first thing I'm going to go after. But before I do that, I want to go ahead and see if there are any sensors. Now, what this does is it actually looks for mirroring. All right. It sees mirroring going to port 5. So that's what I'm interested in, hiding from when it comes time to go after that server. So very easy to use this tool and to have fun finding out what is on that network, what people have available for me. All right, now so once we found our network and we have the lay of the land, same network, the attacker then can grant himself access, isolate the administrator. I mean, it's only fair, right? Hide from that IDS. I'm going to make a little blind spot in that IDS, and that leaves us free. Not you, of course. You won't do this. Free to attack the server. Now, the next tool, of course, as I typed in it earlier, OF access, modifies flows on the network through the open flow controller, adds remove access for host, applies transformations to their network activity. I won't be doing that today, but it actually allows you to write your own flow rule in there, make changes to whatever you want in those 12 fields. And it also allows you to remove mirroring, right, to hide activity from sensors, put in those blind spots. Works pretty much the same way as OF access. That's our OF map. Works with Floodlight and Open Daylight via JSON, auto detects, alternate ports, put the credentials in there if you need to. So there we go. We'll demonstrate. Now, before I do that, I want to show you what the network currently looks like, and that I am not rigging anything, of course. So if I'm going to grant myself access to that server, I want to demonstrate, of course, that I don't currently have access. So I don't think we need to wait for all 4, do we? All right, so there we go. So OF access, I'm going to go ahead and allow traffic for myself. And on this switch, that's where the flow rule is going to go. Priority is important. The tool right now overrides. It doesn't remove rules. It's actually probably a little safer. That way no one notices anything's missing. So right now it overrides, so it needs the highest priority, especially with Floodlight. Floodlight demands the highest priority, so I'll take this default priority here. And then I'm going to go ahead and confirm this. See, I said user-friendly, right? So there we go. All right, go back. There we go. Nice, easy access. Thank you. I did say something about the administrator, didn't I? Not that I'm vengeful or anything, but let's go ahead and remove access for him. And I'm going to show you his access right now. Currently has that access. We'll go ahead and leave that running. Now I'm going to go ahead and drop his traffic. To the server on that switch. See, it helps to copy that because I really would not want to type that. Highest priority. Okay. And back here, and you'll see they stop incrementing, and we should have some packet loss now. So 30% loss already. So I just denied his access. Okay. Now there's still a sensor out there. So let's go ahead and hide from that sensor. Let's actually demonstrate that. Of course, I like to demonstrate. All right, so we're looking at H5. I think that's the right one. I'm going to go ahead and ping the host and demonstrate how it shows up on that sensor. Okay, very quick. All right, so all 8 packets, both directions, showing up. So now let's go ahead and hide. Play hide and seek. So we're going to go ahead and deal with this 2 ways, or 2 different kind of steps to it. We're going to go ahead and drop them or stop the mirroring occurring in both directions from myself to the server, and then anything back from the server to me. So we're going to go ahead and hide from the sensor. Hide myself first, anything heading toward me. Take it off port 5, yes. And then we'll go to the other side of that. Switch 5, a little too big. Okay, so both sides are now hidden. Let's go ahead and first off set this up again. Wrong one. And we should see, of course, nothing, assuming the demo goes well. Okay, so 0 packets captured. Voila, it's disappeared. Okay. So now, to say it crudely, we're now free to have our way with the server. Okay, so there we are. Yeah, it's always good to have this, right? So we've had our way with the Floodlight-based network. There's Open Daylight. Open Daylight, sorry, Linux Foundation. We're going to go ahead and demonstrate. It was a 0 day. It's not a 0 day anymore. I released this after DEF CON. However, I have not released the actual exploit code. I will be releasing that very soon after Black Hat. Okay, in fact, in the next week or so. Talk to the vendors, not much interest. Not much interest. Some talk between individuals, but not really the organizations themselves. This one, the particular with Open Daylight, I actually tried to contact them. They don't have any sort of dedicated resource. They don't even have an email. I used the generic web form, and nothing, well, I can't say nothing happened. Something happened. I got added to the mailing list. So now I get all these messages from them, and I'm like, thank you, okay. You won't take anything from me, but you expect me to take something from you. Okay, so Open Daylight has other southbound APIs besides OpenFlow. Tries to be, just a more extensive platform, more support for more technologies, allows you to also bridge over from the past to the future. They're trying to do a good job, with this. They're trying to support the networks, but what they find is they're not taking care of the security on these when they put these things up. So there's no encryption on that southbound netconf API because they chose to put both TCP and an SSH-based one there. So the TCP one is sitting there, and there's no authentication on it either. You can just connect and exchange messages, which never works out. It's XML RPC based, and I don't know if you remember over the summer, there was a whole batch of XXE stuff that came out. And if you're familiar with XXE or external entity injection, Java has a really big problem with it. It's unsafe by default, which we never see that. So we're going to see one here. All right, so boom, goes Open Daylight. And my favorite, it runs as root. Needs elevator privileges. So that's always special. All right, so we'll demonstrate. I'll get out of here. I tweaked the exploit a little bit, made it user-friendly as well. All right, so defaults, it gives you some hints there. All right, defaults to the password file, but I am greedy. Okay. It has a nice little conversation with the controller, and then forces it to dump something out. Shadow file. That was quick. This is a much better network than the hotel. All right, so we'll go down here, and I've been doing this a lot. So, yeah, there we go. There we go. So the hashes, offline password, guessing attack, you're going to get it. All right, then you go after the controller, get the credentials, turn around. Well, hold on. I won't spoil the surprise. Okay. Turn around and do the same thing. But it's important to keep in mind, if there is no exploit, the service is not available, or they fix it, I don't expect that anytime soon, not to worry. Just password guess. Right? Default password is weak. Strong passwords turned off. No account lockout. Another one of my favorites. And there's no syslog output. So you can pound on it, and pound on it, and pound on it. And really, if no one's paying attention, which they probably aren't, then there you go. All right, so you repeat, you know, and then own that network too. All right. So pretty good. Now, yes, of course, there are other exploits waiting to be found. On Floodlight, the northbound HTTP API, I already found one myself, okay, which is, I'm not covering it now, but it's in the white paper. It kind of directs you into what this is going to turn out to be. It's very simple, and they say that JSON's safe. Not exactly. All right, so there's also southbound OpenFlow API. Open Daylight has a whole lot of other services. We talked about the SSH version of the netconf API. We have the usual suspects we talked about, the northbound HTTP API, OpenFlow API, and the southbound netconf debug port. Debug ports. All right, so JMX access, OSGI Council, a whole lot of other services. What do you know? They're also XML based, and they're being run by Java. All right, so you can guess what you might find there. So go out there, find them. We got to poke at these things. These things are going into production. We need to make sure they're safe. All right, so we need to demonstrate this so that they fix these problems. All right, now available solutions for this, because it's great that we demonstrate that these products have these problems. Until they fix them, we need to have a solution for protecting ourselves and protecting our network for now and for the future. Okay? Transport layer security. They've got to finish implementing the standard. If you're going to put it in, and you need to put it in, do the whole thing, all right? Put the encryption in, yes, that's what you get with TLS. Authentication, do certificates, it's not that hard, right? And the nice thing, as we move to commodity switches to support this, we'll have the cycles. That's probably the biggest complaint. It's, you know, it's math intensive, you know, it's computational intensive, I guess is the way they refer to it. That, you know, we can't do this, but with commodity switches, you're gonna have the spare cycles for this, right? And of course, hardening. These environments need to be hardened. And then VLANing, and these are all very simple things we're supposed to be doing. But we find often that they're not being done before they put these things in production. You know, too many flat networks out there. And then code review. Please, please code review. I can't believe either of these products are code reviewed. In fact, I know after talking to one of the vendors that it was not code reviewed. I guess they don't have the resources for it. That's fine. Make some. Find some resources for this stuff because it's just way too easy. Okay? Very simple things for now. The future is a little different. Okay? We need to begin to think about how we put together these environments, the bigger picture. To protect against denial of service, it's going to be all about SDN architecture. Right? Network partitioning. Slice of that network, have different sets of controllers handling different aspects of different parts of the network. Controller clustering, you're talking about an HA situation. Great. And then, of course, static flow entries. For the most part, these controllers are operating in reactive mode, meaning that everything is kind of a blank slate. And they instantiate those rules as packets are encountered. If you have an idea of your network, and I hope you do, lay a groundwork of static flow entries if you can to make sure that there isn't so much dependency on that controller. Right? Changes can be made on the fly while it operates. But starting out, put those static flow entries in there if you can. It releases a lot of the burden on that controller, but it doesn't have to respond to every single packet that comes along. Okay? So that is what we can do to protect against denial of service. Modification. All right, these controllers are, for the most part, ecosystems. You have applications that are sitting in that environment that are in charge of different parts of the network, different parts of flow space. Go ahead and put in a security-based application. There are traffic counters available. There's full visibility of that network. Have a secondary security application that can check the counters, detect based on policy, based on the configuration of the network and what it should be, respond to abnormalities. Have these things, since you can instantiate rules into these flow tables as things go along, have them detect, have them read the counters, detect variations, and respond to abnormalities. Have something watching the network, right? Have the environment manage itself. And then verification, right? Before you put these applications in place, you can do something called header space analysis. What it does is it turns those forwarding elements into mathematical formulas. The packet becomes a set of numbers, right? You can push it through these formulas, you can do it with header space analysis, and you can figure out how this is going to work before you put it. No more guessing. We hope this is going to work this way. We think it's going to work this way. With header space analysis, you can know exactly how it's going to work. So you can do this before you put the applications in place, and then use secondary security applications to kind of watch to make sure they stay that way. All right? So these are the kind of things that we are going to end up doing. I hope we end up doing to protect that network and to keep it safe, right, from the kind of modifications that I did today. Now, so these are some serious issues. How many of us are going to have to be concerned about this? Well, how prevalent is this going to be? Gartner sees it as one of the 10 critical IT trends for the next 5 years. That's 5 years. Not 10 years, 5 years. So the academics look at this and they see this having a really big impact on our environment, seeing us moving toward it. Major networking vendors see it as something that's going to be part of their strategy, so much so that they're investing their money in it. That tells you how much they believe that it's going to be there. How about the people who would actually be asking for these products, right? Companies can be wrong. What we find in surveys, 60% felt that SDN would be part of their network within 5 years. 43% already have plans to put it into production. So these are issues that we're all going to have to be worried about. We're all going to have some sort of concern regarding this to make sure that we do not fall prey to these sorts of exploits, right? Not only are we going to have to worry about it, we have to worry about it now, right? It's actually already here. Data centers in the cloud are considered the killer app. In fact, that's where most of the movement is right now. Nippon Express, Fidel Investments, VMware, big in this space, but it's also moving toward the LAN, or in the LAN, Caltech, CERN, and of course the WAN, Google, NTT, and AT&T. In fact, Google has it operating one of their backbones, their international backbones. So they're pretty invested in that now. It's coming, it's here. So that's something we're all going to have to be concerned about. Okay? We want to be concerned. We want to be checking not only these controllers, but our own controllers that we have planned to put in place or have in place now, right? Because this could go very right. Vendor independence. Who here would actually like to leave their vendor? Right? Anyone? Anyone? Thinking about it? Yes. Not only vendor independence, but ultimately lower cost. Networks that match the application and not, the other way around. Right? Faster evolution of the network. You get production scale simulation and experimentation. You can try out right now how it's going to work. And you can even, I know you can't do this practical reasons, but if you wanted to change the network after deciding on the proper configuration, you could actually just change it right there. You could actually move aspects of the network around. That's network function virtualization, another talk, but you can actually move that network around immediately. And then you can gain truly dynamic and active defenses where you can actually begin to have that network defend itself. So these are really great things that you can do with software-defined networking. So it's important that we do it right. But as it could go very right, it could also go very wrong. Okay? Denial of service. Peer node. We want to have everyone gang up, play dog pile, something like that, right? Gang up on one of the other nodes. How about an external node? You harness one entire network, slam it against another network. A single host, right? It makes botnets look like toys. And then, of course, the inverse, which is selectively dropping traffic. Important message just disappears. Transaction goes away. Right? We talk about subtle manipulation. Speaking of that, man in the middle entire network, local subnets, individual hosts. You get very ninja there. You can start modifying transactions. Drop a couple of zeros off a transaction, add a couple of zeros on a transaction, change the words in a message, love to hate. You really don't want those sorts of things. It leads to the kind of scary things that we read about in these novels, in these books. Futurists talk about, dark nets, networks within networks, Uber admins kind of tweaking things. Yeah, we don't want these things. Right? So we want to go ahead and make the difference. Traditional means of securing controllers still apply. Right? But security needs to be part of the discussion. Until now, it's really been about how SDN can help security. But we need to start looking at, as security professionals, people in IT, how secure is SDN before these things go in to make all this magic happen. Now, analysis are being done, but by outsiders. And for the most part, now it's been very two-dimensional. I think this is probably the only talk I've ever seen that talks about this from beginning to end, looking at the totality of the issues involved. We need to start looking at more this way. Right? So, and speaking of that, they talk about the software-defined networking being a network operating system. So we need to actually start treating that way. And this is my kind of 2 cents at the end of this, is that it needs a security reference and an audit capability, just like a standard operating system. If you have this in place, you need to make sure that whatever changes are made are authorized. They have the rights to do this. There's a reference going on. And then an audit capability to figure out who made that change. Who made that change. So this is something that will be important going forward. Okay. Final thoughts on this. SDN has the potential to turn the entire internet into the cloud, right? Slicing everything up. Benefit would be orders of magnitude above what we're seeing now. But there's a hole in the middle of it that could easily be filled. I know the NSA is the bad guy today. China, of course, we like to bang on China. But all the nation states are doing it. Everyone is playing around. Even countries as small as Thailand, they're considering cyber operations. Right? We do not want them involved in our networks. Right? So we need to keep them out, get on these sorts of things. And let's not let that happen. And it starts here. Okay. The toolkit, it's 1.0.1. I made a small little tweak before the talk here. This will be going up after the talk today. I'll be putting it up on, I'm a little old school, it's on SourceForge. But it'll go, wherever it goes, you can find it actually originating from Hellfire Security, so go there. That's the easiest way, because I don't know. I think people have been having some problems with SourceForge. Maybe I'll move. I don't know. But right now I'm in SourceForge. Best way to find it, though, no matter where it goes, is on the main site. There is the hash. Okay. A whole lot of links. The DVD has these, so, and of course the slides will be up online. SDN Central, you can learn a lot of stuff. They're open, networking, the project websites. I highly recommend the Coursera course from Nick Feimster, Dr. Feimster, all about SDN and some other references there as well. That is it. Thank you.